This is video 332, and the goal here is to use logarithms to condense expressions and to be able to change the bases of logarithms. So we will continue to need our properties of logarithms, and then we'll learn the rule for changing the bases at the end of the video. So let's take a look. When we condense, our goal is to do exactly what it says. We're condensing, we're trying to put this into a smaller expression. And so we're going to use our rules and we're going to go backwards. So we're going to take the written out expression and go backwards and condense it again. So you notice, number one, it has to have the same base in order to do this. And we have to know the rules. So since it was plus, it's still going to be log base 4. Since it was plus, it's going to be the product of 2 times 32. And so that's really log base 4 of 64. By condensing like this, we're able to see that log base 4 of 64, we actually know the value of that. Log base 4 of 64 is, in fact, let's see, 4 to the third power. So this is actually just 3. Because 4 times 4 times 4 equals 64. So that's condensing and why it is helpful to us. So let's take a look at this next one. So log, remember when it has no base, it's in base 10. So this is base 10, but I don't need to write the 10. I can just write it as log. Since it's minus, it's going to be a division. So it's going to be 4x minus 3 over x. And that is condensed, and that can kind of be simplified, but not really, because there's no common factor. I can factor out of the top and cancel with the bottom. So that is condensed as much as possible. So another example, let's see. So we have, now we're starting to work with ones where we have factors in front. So there's 1/2 out in front. So before I condense, I need to get it to just be log of x to the 1/2, or think of it as square root of x, right? Because that's the power rule. So when we have the factor out in front, we're going to take it and put it back in as a power. And it's still plus, and then log of x minus 1 to the 4th power. So we have these values, and now we have no factors here. So now we can take and condense this even further by using the product rule. So now we'll use the product rule, and we'll put it back as a product of the inside term. So now we can change it to log of x to the 1/2 times x minus 1 to the 4th. And honestly, you'll probably write that as square root of x instead of x to the 1/2, because it's a simpler way to write x to the 1/2. So there's your condensed version of the same exact quantity. So let's take a look at this next one. We got a lot of subtraction, but we also have, everyone seems to have a coefficient here. So let's bring the coefficients in and change it to log base b of x to the 4th by raising it using the power rule, minus log base b of 6 squared minus log base b of the square root of y. So since both of these terms are being subtracted, they're actually both going to be in the denominator of my using the quotient rule. Another reason why that is we have the subtraction. We could factor out the negative and rewrite this as 6 squared minus, really plus now, because we're factoring out this negative, log b of the square root of y. So that's equivalent to the original statement and to the one above it. Now I can write it as a quotient. So in the denominator will be these two terms, so really 36 square roots of y in the denominator. And in the numerator, it'll have x to the 4th from here, and it'll be still log base b of this whole quantity. So originally that was my quantity, and that is condensed as we can get. We look for ways to simplify, but there is nothing to simplify, nothing to cancel or reduce this fraction, so it is as good as it's going to get. Now let's talk about evaluating. So I'm going to walk you through how to evaluate this value. So we're looking for the power such that when we take 5 to the power y, we get 140. We're looking for that power y. And the trick is it's hard to find that power y because it's not a small number. It's not a number we know because 5 to the power y, we don't know what will give us 140. We could guess and check and get close to it in decimal form. So we're looking for that power y, and we're going to figure out how to use log base 10 or even the natural log. This works with natural log because those are keys in your calculator. Someone has stored those different values in your calculator to figure out what the different values are. And we know them based on the table that's stored in our calculator, just like the sine, cosine, and tangent ratios. So what I'm going to do here is I'm going to actually take the log of both sides. So what I'm going to do is I'm going to take the log of the left, because what I'm essentially asking is 10 to what power a gives me 5 to the y. I'm asking that question when I take the log of the left-hand side. I'm looking for the power a. But guess what? That same power a will give me 140 because 5y to the y is the same as 140. So I'm going to take the log of the other side as well. So I've got the log of 5 to the y, and that will equal the log of 140. Log of 140 is a value that's in my calculator. I can figure out what that value is by punching it in. But the left-hand side, I still have that y there. And remember, my goal is to find y. But look at what I can do. I can use the power rule to drop the y out in front and get it out of the inside. So this left-hand side is really y times log of 5. And that equals log of 140. So take a look at where we're at. We're at a much closer point to figuring out what y is. Because again, we know what log of 5 is, and we know what log of 140 is. So y is simply log of 140 divided by the log of 5. That you can punch into your calculator. All I did was divide both sides by log of 5. So that's how I'm going to find y, and y is the value, remember, for that expression because of the way we defined y. Y was the power we take 5 to get the answer of 140. So in general, the good news is this will work for every value. If I ever want to find log of any base b for a quantity m, I simply, notice what we did, we took the log of m and we divided by the log of the base b. And that will work every single time. Now remember, when we prove things, we want to prove them with general quantities, but all we have to do is go back and change every 5 to an x and every 140 to a z. And we'd be able to prove that this works for every single case because we never actually use the numbers. So that is how we're going to find exact values for logs that are in bases other than e or 10. So let's take a look at this in action. So remember, it's log of the value divided by log of the base. And that works for any log base b of m. Okay, that's our change of base rule that you want to get memorized for future uses. This will always be true. So let's see, for this one, that means I'm going to do log of 2,506 divided by log of 7. So find the log key on your calculator, you'll punch in the top, make sure that you close the parentheses, and then you'll divide it by the bottom. So log of 2,506 divided by, of course that's in parentheses, log of 7. And that's how you'll find your exact value for every single log that's not in base 10. So in this case, it looks like my calculator tells me that this is about 4.02. And I could test this. I could test this, remember, because of what the original statement was. To make sure I believe it, I could test, is 7 to the 4.02 power, in fact, about 2,506? When I punch that into my calculator, I get 2,496. Now Now if I round to one more decimal place and add that 2 here, I will get 2,506.01 when I add another 2. So it does in fact give me 2,506, but it is not a nice number. So it is something that you will have to round to a couple of decimal places. So that's how we change bases. So that's what your checkpoints are going to be on. You're going to, for the first problems, try to condense it using your properties. And for question number 2, you're going to try to evaluate using common logarithms. Definitely check your answer for question 2. Make sure that 4 to the power, whatever decimal you get, actually gives you about 12. Okay? So that's your video for tonight. Make sure you bring in these answers to your checkpoints that we'll check them in class the next day and go over any questions you may have.